Now we're going to look at the graph of the cosine function. And before we do that, I want to go back and quickly look at the sine function. We had y equals sine of x. And if we recall what the graph of our sine function looks like, we have y equals sine of x. Go to zoom 7 for zoom trig. And remember, if we think about starting at the origin, it starts on the axis and then it goes up. So how does this compare to the cosine function? And the good news is we're not going to spend that much time with the cosine function because you're going to find that it's very similar to the sine function. The only difference is where it's going to start at. So if we think of the cosine function here, if we take the cosine of x, notice now at the origin the graph doesn't start on the axis. For the cosine, it starts up here on the y-axis. So it's starting up here at the high peak instead of starting at the origin and going up. It starts up here at the top and will go down. So basically, other than the actual kind of starting point here with the cosine function where it starts at the top as opposed to the sine function starting here, the graphs other than that are pretty much similar. And if you think about this, what if we were to move? Can you think about how, is there any way to shift the cosine function so that it looks like the sine function? If you think about what we did with the sine function, that phase shift, remember if we were to add something on the inside, so for example, if I was to write y equals the cosine of, remember the bx minus c on the inside, do you recall what we could do here to cause that phase shift? Well, it looks like the only difference here is it looks like if I was to take this point here and move it to the origin, okay, so what would happen if I want to move this graph? If we keep in mind here, this is actually negative pi over 2, so this distance would be pi over 2. So if we want to move this pi over 2 to the right, then up here this would become x minus pi over 2. And let's see what happens if we do that. If we look at x minus pi over 2, and I'll go down here and type this in. I'm going to type in the cosine of x minus pi divided by 2. Okay, so if I hit graph, notice we get this graph here. Now notice it's going right here at the origin and going up, and now this is the sine function. Okay, so if I went back here, and if I clear out the cosine and I type in sine of x instead of cosine, now notice I'm going to go and move the cursor to the very front where I get in front of the y1. And if I keep hitting enter, I think it's about 4 times, you get this little flashing open circle. And what that's going to do is when it draws the graph, it's going to actually trace out with this circle. So we can see when it graphs the sine function, we're going to see this open circle. So let's see what happens when we hit graph. So there's the open circle. Here is the graph of our sine function. And then the next graph, which I should have put the circle there as well, now you can tell it's still graphing up here in the corner. This is still going. So what happened is the other function is going right on top of it. So let me go back and do the same thing for this cosine function. If I go in front of the y2, I want to change this to the little open circle. So now it's going to trace out both of these, and we can realize that they actually turn out to be the exact same graph. The only difference with your cosine and sine is that they have that phase shift of pi over 2. So if you notice now, look, the second graph, it's tracing right over the same. So therefore, we're ending up with the exact same graph. So the sine of x and this cosine of x minus pi over 2 is going to give you the exact same graph. So if you recall all the things that we had talked about before with our sine function when we had y equals a sine of bx minus c plus d, that's going to still be true for the cosine. Y equals a cosine bx minus c plus d. So whether you're looking at the amplitude, the period where we use the b value, and then the bx minus c was dealing with the phase shift, and d is the vertical shift, all of that's still going to be the same way that we calculated it over here for the sine function. The only difference that you have to be aware of is, like I stated before, is that the sine function, when we go to do the graph, it starts down on the axis, whereas the cosine function starts above the axis. So if we're thinking of this as the axis here, the cosine actually starts up here above the axis. Now, of course, you probably could guess if we were to put a negative with the a, if there was a negative in front where we got the reflection, then instead of starting up here above, then for the cosine, it would actually start down here below. So therefore, you're getting that reflection due to the negative sign. So other than that, all of the other calculations would be exactly the same. So if we just look at a couple examples, so if we had y equals, let's say, negative 4, let's try a fraction here. What if we had, say, a negative 4/5 cosine of, let's see, how about 4x minus 7? So here, if we wanted to calculate the amplitude, then it would certainly just be the absolute value of a negative 4/5. So the amplitude would be 4/5. And if we were trying to calculate the period is simply 2 pi divided by b, and here 4 is our b value. So 2 pi over 4, we would end up with pi over 2. And if we had something like, let's say, y equals 4/8 cosine of, let's say, 6 pi x plus 1/3, if we want to know the amplitude, the absolute value here of 4/8 would be 4/8. Now, of course, 4/8, we could simplify that to lowest terms. 4 into 4 is 1, 4 into 8, so we would end up with an amplitude of 1/2. And then if we're going to calculate the period, again, we're going to use this b value, so the period is going to be equal to 2 pi divided by 6 pi. Now notice here, the coefficient is not just the 6, because the pi is also part of this. We're looking at the coefficient of the x, so we're using the 6 pi here. So 2 pi over 6 pi, the pi's cancel out, and you're left with 2 over 6, and 2 into 2 is 1, and 2 into 6 is 3, so we end up with 1/3. Okay? So be very careful here when you're looking at calculating the period. You want to make sure that you actually use here the coefficient. And then of course here, if we wanted to look at the phase shift, then the phase shift, we would simply just take the 6 pi over x plus 1/3, and we could set that equal to 0 and simply solve for x. So we would have 6 pi x equals a negative 1/3. And then if we solve here, we would get x equals a negative 1/3. And I guess the easy way, if you're dividing by 6 pi, we could think of multiplying by 1 over 6 pi. So therefore, x would be equal to a negative 1 over 3 times 6 would be 18 pi. So here it's a negative 1 over 18 pi. So that would be the actual phase shift. So if you can really understand the amplitude, the period, and the phase shift, you're probably in pretty good shape with determining your graph. So again, there's kind of the key points to calculating amplitude, period, phase shift, and then of course, if we were to add on some other value here at the end, that's just going to simply move the graph up or down. So once again, for the sine function, keep in mind that the graph starts on the axis, whereas the cosine starts above the axis. And the reason that happens is you can certainly compare this to the unit circle, and you can make a chart to look at this. If you think about starting at 0, pi over 2, pi, as we go around the circle, keep in mind what your coordinates are. Here we have 1, 0. Up here we have 0, 1. And over here we would get negative 1, 0. Down here we would be at 0, negative 1. So if you were to make a chart, and I'll let you finish this up, I'll kind of start it for you. But if we're looking at the sine function, y equals sine of x, if we were plugging in values for x and getting out our y values, when we start at x is 0, that is our y value. So here we get the sine of 0, which would be 0, and at pi over 2 up here we get 1, and we could keep on going around. If we look at y equals the cosine of x, and we're looking at our x and y values, so if we start at 0, we get out a value of 1. And then if we go to pi over 2, we're getting out 0. So that's why when we look at the graph of our sine function, 0, 0, we start here and the graph goes up, as opposed to the cosine function, because at x is 0, your y value is 1, so it's starting up here and then going down to 0. So that's kind of the difference as we go around the unit circle, because of the sine function starting down here as opposed with the cosine function starting up above the axis.